all this.
Okay. Okay. We're in good shape.
Thank you.
Okay. Okay. Great. Okay. So I'd like to introduce our speaker who just managed to overcome a failed machine, failed drivers, failed network connection, lack of an R library, and failure of audio. And she comes to you through all these hardships to brief you about some tools that we've developed to help automate various aspects of output from any logic. So please join me in welcoming Priyasri here.
Thank you. And I will start with apologizing to everybody. It's really, you had to wait and Nate had to go through all this. And I don't know why my machine selected today, this date. Anyways, so just give me 1 second. Does it work?
No.
No, I have to click on this Cam Studio thing. I have to send it
Just
back.
send that to the background. Click on this guy here.
Okay.
Yeah.
Now this one
I
works.
don't think that will work.
Yeah, this. Oh.
No.
No, I don't need it. I don't need it. I was just checking. Yeah, I can check. I can use it. That's fine. Okay. So you all know my name. I am Priyasri Bhomik, and today I am going to talk about a tool that we have developed with aspect-oriented programming, and it's basically developed to generate some additional outputs that will help modelers like us who work with simulation models, and especially who work with any logic to build simulation models in any logic. So modelers like us who have worked quite a bit with simulation modeling and any logic has sometime or the other come across certain small challenges or difficulties or limitations while working with any logic. Although we greatly appreciate and enjoy all the benefits that any logic provides us in the context of simulation modeling. So what are the greatest difficulties that we come across in modern times? The major ones are the lack of logging and tracing mechanism. It does not provide us an inbuilt mechanism of logging and tracing. And another one would be the lack of an automatic storage of generated results. We do create a lot of results from these models, and there is no good mechanism to store them automatically. At times, oftentimes it seems to be a very difficult thing to deal with. So now, if we like to see why tracing and logging are so very important to us, well, these few slides will show us why it is. So many a times a modeler needs to run the same model again and again to overcome or to go through the different test case scenarios that he has in mind. So multiple reruns are required to illustrate different executions of the model. And it is so very difficult to manually document the results from each of these executions. It's next to impossible to document each and every detail. It leads to unnecessary, I'm sorry, what happened? Why the key is not working? The key is not working. So, yeah, it's working again. Thank you. It leads to unnecessary rework and wastage of time. And the third point relates to the concept of a random seed that is used in the models built in any logic. It is, I'm sorry, there are so many. Oftentimes, we see that the modeler needs to recreate the exact same afterwards. Maybe he remembered something he had done last time, and based on that he wants to develop certain other things, and he needs to recreate and see the same exact output. But if he had not selected a fixed seed at a prior time, then it is very difficult for him to regenerate the exact output, because it's very difficult to realize or get the value of the seed that was randomly generated by the model. It leads to unnecessary complications when such a need arises. Now, coming to the problems that we face due to the absence of a tracing mechanism, The only ways of tracing that AnyLogic provides us is via the use of trace elens and print statements. Through these days, we have used trace elens a lot, and maybe you have also felt that it's so cumbersome. We have to write so many lines of code. So many lines of codes need to go in, and then afterwards, when you don't need those traces and you need some other traces, you have to remove those lines again. So it's basically a complicated, cumbersome task, and it's too time consuming. And two more points that I want to specify here is that if your model has a very large number of they contain a very large number of trace statements or print statements, then many of you might find that the console doesn't give you the entire trace log. That is, the console it like truncates a few trace statements. It doesn't have the capacity to give you the entire thing. That is one problem. Another problem is that we found that it doesn't give the traces in the correct sequence. Maybe A happened first, then B, then C, but while the trace statements are produced, they are showing C first and then B, then A. So like it kind of confuses the modelers a lot. So it's not a true tracing mechanism, and it gives rise to many difficulties. Then the next point relates to the fact that many a times modelers are not the end users. End users are the ones who need to gain the most from the models, but unfortunately they are not present when the models are executed. The modelers run the models, and they are the only ones who witness the models, the execution of the models. So users are unable to grasp the insight provided by the simulation model, which is very important. And the only way to overcome this might be going through the traces if we had an efficient and a detailed trace log present in front of us. The third point relates to basically the first 2 points, that the simulation models are often quite complicated. It involves a lot of factors, and that is the reason, like without a trace log, it's very difficult to verify the correctness of the model, because we don't know what exactly is going on behind the scenes. We know what we have built, but we don't know if our building mechanism is working as we wanted or not. And the debugging activities also become a challenge quite sometimes, like why is this not happening, what exactly did I do wrong, and things like that. So a trace log helps a lot in these scenarios. It tells us what happened, like in a timely manner. So these were the basic difficulties. Now coming back to this tool, here is a little background about it. We created this tool with aspect-oriented programming, or Aspect-J to be more precise. Aspect-J is an aspect-oriented language that is a well-integrated, compatible version of Java. Extension of Java. Sorry. It emerges as a resolution to the issue of cross-cutting concerns. So cross-cutting concerns are basically issues where we have the same functionality spread over multiple classes. A classic example would be authorization of a debit card. Like when we try to check our balance, the debit card needs to be authorized. Similarly, when we try to withdraw some money, then also it needs to be authorized. Again, when we try to put some money into our account, then also they need to authorize the card. So all these are discrete functionalities, so they are contained in different modules, but they have a function in common. All of them have a function in common. And aspects allow us or help us to get over this issue. And the next one is that Aspect-J provides new constructs called aspects. We call these constructs as aspects, and in my title I was actually referring to this aspect. So we have made an effort to address some of these limitations of the simulation modeling framework, AnyLogic, and to that end we built an automated logging technique that we refer to as the run log, and a tracing technique that we refer to as the trace log. So the run log and the trace log would enable the users to see the details of the activity behind the scenes without making any change in the code of the model. You just need to configure the tool into your model, and the files will be generated automatically, which will tell you, which will give you details of the entire execution. And this will facilitate more testing and less rework, since you don't need to be bothered about like noting down certain information from your execution or things like that. And it also improves the robustness of the model by allowing efficient way of debugging. Certain times you might see that at 20 units of model time you were expecting to see certain things, but that is not happening. You might go back to your trace log, check what happened when 20 units of model time, at 20 units of model time, and you might see whether the actions took place according to your expectation or not, and then maybe go back and change certain things accordingly. So this is the overall implementation of the tool. We have created this tool with Aspect J, and we have tested this tool with AnyLogic version 6.9, and we are working towards extending it for version 7 as well. So today I will show you everything with AnyLogic version 6.9.
Cut off to the bottom. I'm just going to do something to fix it here.
Okay, thank you. I can still use this key. Yeah, thank you. So here we basically see a modeler who is running several simulation runs of the same model. It is a single model which contains 3 different executions or experiments. So run 1, 2, and 3 denotes 3 separate experiments. And each of these experiments actually create a subfolder which contains all the results from the experiments. These subfolders are indexed with date and time, so that whenever a person refers to in the future, he can know exactly which run he is referring to. And we can see from here that when aspect tool is applied to the model, then we get a set of additional outputs which are beyond the typical model output. So number 1 denotes the typical model output that is created by the model itself without the aspect tool. But number 2 through number 6 denotes the outputs that are created as a result of the tool. So number 2 refers to the run log, which provides us with the summary level details. I will tell you in detail what the run log contains after a few slides. Number 3 refers to the trace log, which provides us with the details of what is exactly happening behind the scenes in the model. Number 4 and number 5 refers to the output canvas. So it shows us the initial state of the model and the final state of the model. By that I mean that when we click on the run in the experiments, then a window pops up. So we are capturing that image as the initial representation. And when the simulation completes, then it shows us the complete graphs and stuff like that. That is captured as the final representation. And number 6 refers to the version of the ALP file or the model itself. This is actually preserved because we always keep on giving or adding new functionalities to the model and changing the model a little bit here and there. So in order to recreate the output, we need to have the exact same version of the model. That's why we are preserving the model as well. And the next few slides will tell us how to configure this tool. So actually, basically, we have actually 3 very simple steps to do that. The aspect tool consists of library and classes. I have included source here just because if somebody wants to change the tool a bit, maybe to add certain other features to it, then he would need that. Otherwise, library and classes is all that is required to use this tool as a part of the model. We need to copy these 2 folders into the folder containing the project or the PPT file, the ALP file. And once that is done, then we need to add the classes folder into the project in the AnyLogic. So we need to select the project, go in the dependency and add the classes folder. That's how we add any external jar files in AnyLogic. And after that, we need to add the Java command in the JVM argument within the model. And this needs to be done for each and every experiment present within the model. Because if you have two experiments in one model, you added it in one and not on the other, then the one which contains it will only give you the results, the additional output. The other will not provide you that. Once this is done, we are set up with the tool and we are ready to, we are ready to generate this output, this additional outputs. From then onwards, whenever we run our experiments, and a new folder will pop up or will be created every time. The folder will be named something like this, that is, it is indexed by the timestamp, the date and the time, and it will contain these 5 things. So these two are the images, this and the log file and the trace file are actually text files. So it will contain the log file, the trace file, a version of the model, and the 2 images, the final and the initial image of the model. And let me now talk about in details what is contained in each of these files. So first of all, we have the run log. The run log provides us with the summary level details of each execution. By that I mean that it provides us with details like the start date and time, when one started the experiment. It tells us whether a random seed had been generated by the model or whether a fixed seed had been used by the user. It gives us the name of the experiment. This is actually required when we have more than one experiment for a model. It also provides us with the parameters which are governing the model. By that I mean that the parameters which are present in main, those are actually presented here. Those are actually preserved or stored here or written here. And finally, it provides us with the end date of time and the total time taken by the experiment to complete. Next comes the trace log. The trace log provides us with all the inner details. First of all, it writes each and every activity or action indexed by time. So we get to see at what model time something happened within the model. And it provides us whenever there is a change of state, whenever an agent changed from one state to the other, like from maybe as an example, maybe from diabetic to non-diabetic, from non-diabetic to diabetic, and things like that. Then it provides us with the information of the transitions that are responsible for that change from state A to state B. And it also provides us with the message that is sent or received by the agents. And we are also working to include the events. It will provide us with the information about whenever an event is triggered or an event is, generating any message or things like that. This slide shows us the initial and the final presentation. These are the output canvases. 2 image files are stored. One image file shows us the initial state of the model, and another one shows us the final state of the model, how the model looks like when it completed the simulation. And finally, we save a copy of the ALP file. So basically, we can actually run this ALP file in future if we want to recreate the exact same output. And that is more or less everything. To summarize, simulation modeling with aspects provides a great amount of flexibility to the end users. It enhances the efficiency of the entire process. It leads towards a better design. It allows the users to gain from the first-hand experience of running the models. This is especially true for the end users who are not the modelers themselves, and they might read through the trace files and see what is going on in the model. And it is extremely useful and helpful for applications used by doctors or public health researchers, or to be more precise, people who are not from computer science background and who do not find it very comfortable to add lines of codes whenever required. So that is basically all about this tool, and you can note my email ID if required. You can send me an email, and I'm open for questions. I'll also show you a demonstration of the tool. Yeah.
One question. So,
sure.
In a lot of the discrete event software that I work with, discrete event, you have the idea of an event calendar. So I'm just curious, like, does AnyLogic maintain that event calendar for
event calendar, like when one event is happening?
Yeah, because like in discrete event simulation, typically the way is,
Oh, I did it only for agent-based modeling.
Okay.
I didn't do it for discrete event.
But the answer is yes,
but,
there is an event calendar which is basically by AnyLogic beneath the surface.
But the events in sort of the AnyLogic environment are separate from that.
They contribute some of the events handled by the event calendar, but not all. Yeah.
Okay, so that's like, I guess I was just trying to understand like why events couldn't be easily pumped out into the tool as you structured it now. Like, what if there's, I'm just curious where the difficulty is coming from there.
No, it's not. It's difficult. Right now, the code that we have doesn't. We do not have code for like capturing the events, but we are writing the code for that. It's not that it's difficult or something. We missed it out actually. And while I was presenting the last time, then the audience over there pointed out that okay, event is missing, and then I started thinking about it. So I'll just incorporate it. It's not because it's difficult, so it's left out. It's not like
the more substantive software engineering issue is that it's fairly easy for us to figure out how to do it with a given version of AnyLogic. The question is, we want a guarantee in place from AnyLogic they're not going to change that willy-nilly and break our tool. So as soon as they come out with 7.1, that our tool is not going to stop functioning. So this is an issue of having a contract from AnyLogic, not in a legal but in a technical sense, saying that we can count on these interfaces being guaranteed, and that if we hook in at these places, that will be maintained, in among broad versions of AnyLogic. And that's what we're looking to negotiate. And that's the more sort of substantive issue. A similar issue comes up with her recording of the random seed.
Yeah.
She has to kind of spy on, when it generates one automatically, she has to sort of spy on what's going on.
And it's kind of a little difficult to find exactly which is a seed that they are generating. I think we need to talk to them regarding that also. We should have a way of like getting or like capturing the random seed even when it's generated by the model. Otherwise, it will become close to impossible to recreate the exact same output whenever a random seed is used.
We try to overcome that by generating our random seeds ourselves and having like a functional way.
Yeah, that is something we have also tried. Generating it randomly ourselves and then try to push them as a random seed. Yeah. Any more questions? So yeah, I guess I would show you how I'll like just run one model and show you how it works. So here is one model. PPT1, in which we have applied the tool, like I'll show you if we see into this dependencies tab, you can see that classes have been added here, and I'll be running this small population experiment. So in the advanced tab, you see that in Java machine arguments, this Java command is also added. That is all it requires to like configure this tool. And if I add it now, if I run it now, I'm afraid that some of the graphs will be truncated because of the setup, the size of the screen. But just quickly complete it. So this is a folder which is created. What is the time now? Is it 12:50? No? But it was sure.
Go over to the left-hand side, 303.
Oh, yeah.
Yeah.
It's 1:49. It's not 12:50.
Okay, go update it by clicking on the name of the thing at the top.
Which one?
Yeah, go click on the folder name at the top.
Okay. Yeah. No, I refreshed it from here also, but it's. I don't think this is this. I think this is the last one that we were just testing with.
Yeah.
Yeah, but I think that is also outdated.
Here, could I?
Oh, right. There is one in the between. Okay, here. Yeah, this is exactly. The one. Yeah. Sorry. So this is the log file, which provides us with the date and time. And this experiment is using a fixed seed of 1. So that's what it is showing.
And if that was a random seed, it would tell you the random.
It would. Yeah. If that was a random seed, I can run it once more. It would tell you. And this model is called small population. So that is what is shown here. And it has one parameter, which is population size, and it is of type integer, and its value is 100. And then again, it shows when it completed and how much time it took to complete the experiment.
Priya,
yeah.
If you could just clarify, if it were a random seed, would it actually show you the particular seed value?
It will, but the seed value is something that we are actually randomly generating and like pushing it. So it's not actually what the random seed has been generated by the engine behind, because that is something we couldn't capture.
Exactly, but this one would allow you to completely recreate that.
Yeah, this one will. And next is the trace file, which gives you with, like, it's a long file with all sorts of data. So it gives you with all the details, like what is the state of a particular agent, what is the exiting state, what is the the agent is entering into which state. Like from pregnancy, the agent is exiting from the state pregnancy and entering into the state postpartum. So that is the first two lines show that. And it also shows via transition preterm delivery. That is the name of a transition in this particular experiment or in this particular model. So it's like this. It gives you all kinds of details of what is happening at what point of time. And this is a final image. And this is the initial image. And this is a copy of the ALP file. So do you all want me to run once more with a random seed? Okay. Let me change that. Give me 1 second. So here it tells like this: the random seed generated by the model is and gives a value. Yeah.
When you list the parameters, are those the annualized parameters?
Yeah, those are
for all the objects in the model?
For the main. I mean, whatever parameters you have added in the main, those are the ones we are capturing.
Because
those are the actual governing.
Determine the values for all the other agents collectively with the random numbers for the model. That will dictate what parameters pass to the agent.
So by saving the analogic model too, you could also drill down if you wanted to find out separate parameters that were set for population, something like that. That's all.
Yeah, you could. You could. By that, you might refer to the parameters that were added in the person class as well. We can capture them also. It's only that we are adding more and more data, and so much data is not required. Like the main objective of the run log is to recreate the exact same output in the future. So all we need is a random seed and the parameters that are present in the main, because they are governing the entire model. So that's what we are trying to capture, and the date and time, and of course the experiment name, because if you have 5 experiments for one model, then you might very well get confused, like which one I ran at this date, this and this date and time. And the date and time otherwise is required just to like refer. Whenever you are referring to it, it becomes very easy to think maybe last week around morning I ran this model and let me find out what was the result and things like that. Yeah, yeah, sure. I'll show you and I'll tell you from there. No, no, these are also part of the trace log. I mean, in the trace log, you can capture a lot of different stuffs, but the general, we have captured here some generic stuffs that are required. So some of them are like whenever an agent is exiting from one state and entering another state. So like here, you can see exiting state participant, it's giving that unique ID of the agent and the state from which it is exiting, and it's also telling us the transition via which it is exiting. So, and then in the next line, you will find that it is telling us where it is entering. After exiting state, we have this entering state as well. So entering state, and then the state name, and also via transition. So, I mean, this is about whenever there is a change of state. Similarly, whenever there is a message passing, there should be some for message also. I have to look for them now. Let me find one.
So is this what you were asking about, David, about adding events to the trace log, or was that something else?
No, he was asking about events as such, like the events that you created today. You were talking about those events, right? The cyclic events, or yeah, yeah. And this is an example of a message, like this agent is receiving this second pregnancy message from this participant, I mean from itself, because that's how this model was designed. So these are some examples of like we have the timestamp, and then we have the activities, like whenever a message is being passed or whenever a state change is taking place, and which transitions are responsible for the change of state. So those are the things which are basically captured now, and we would also add this event thing into it. Yeah.
Are those separated by tabs?
They are actually.
So you could load it into
We should be able to load it into Excel. Yes.
Filter columns according to the particular age.
That was the idea, because we have used tabs to load them. I mean to write them. Are there any other questions?
The only thing I see is that you're talking, it seems to me like you could use this to recreate those histories that we were talking about, but again, the agent is in the population, right? So if you wanted to capture the person whose ID changed, then we have to do something.
No, actually, the IDs concept is the one which Nate taught us yesterday, ID and next ID. Right. So a person's ID never changes.
So you're using an ID here, not an agent number?
No, not an agent number. We are using an ID, not an agent number. So, I mean, one is always one. Either you will see him or not see. In this case, her, all are females here. So either you will see that person or not see that person. Initially, all 100 or whatever the size of the population, they will stay. And then for mortality rate, or we have some different scenarios under which a population might be removed, a person might be removed. So you will find them just going away from the experiment. But the number never changes. Yeah.
I'm not sure if you changed it or not, but where do you change the seed?
Where do I change the seed? Oh, for changing the seed, you have to do that right here in any logic. we have an option in general where under random seed generation, we have options. You can like select if you want a fixed seed and whatever the fixed seed value you want to be, and otherwise random seed or custom generator. I mean, we have these three options.
And the point is that her tool, even if you say random seed, her tool spies sort of on what's going on and injects our own random seed that's completely known into it so that we can precisely specify what the seed is with which this model has been run.
The whole objective was to recreate the exact same output whenever required. So I guess apart from this,
I'm just curious. So
yeah, should I open this up?
yeah,
Okay.
The trace file. So the trace file is recording by time. Is that? I mean, I assume from the way you described it, that's the exact order of events that's actually taking place.
Yeah.
So for the zero time events, like that's the order in which the zero time events actually.
That is right. If you see, you will see 0 first, then 1, then 2. And we have this 4, I mean, the same thing is repeated 4 times because this model contains 4 separate state charts. So at 0 point, like all the agents are starting from the initial pointer of each state chart. That's why they are repeating 4 times here.
That's right. But at events at time 0, you know, if there are events that occur at the same precise model time, I lack conviction that any logic, the console lists those always in the same order. Both Priesri's team and myself have encountered cases where it appears that, and I think it may be this case where they're occurring at precisely the same, model time, that they're in the opposite order in which they're actually handled outside of her tool. And her tool was partly designed to give total clarity as to what order things were occurring. So what I'd say is the console is quite good in general, but it can only handle so much stuff. Otherwise, it disappears. And secondly, sometimes things I think at the same model time get reordered a little bit.
Is that a feature of any logic, or is that a feature of like just the way any logic is doing its Java thing, or is that a
No, I think it's something about how any logic is reporting those things. I don't see any deep reason why it would have to be that way, and I'm planning to take this issue up with them because I think it's an important issue. But this tool would give complete clarity as to the actual order.
You're saying that on the console you could run out of space.
Oh,
yes.
You certainly can.
That's
when
when.
All the time.
I was hoping that there was a parameter that expanded it.
It may be a 7 there is, but at 6.9 it's very limited. What you could, I think it just was run out after 2001. I'm not sure it's 7. I have to go back and check.
Yeah, the question which you asked about the console, that out of sequence scenario I was explaining while talking about why trace LNs are not very reliable. Like they are good most of the time, but then you are not sure if they are good or not. That is even more dangerous.
The relative ordering of them, if they occur at the same precise model time, I think is questionable. Yeah, I think if they're, and one is time 10, the other is at time 15. I think they're the order.
Yeah, right. That is correct. I mean, we came to know this because we faced a scenario where like things were happening not in the way we had expected, and we checked it several times and still we couldn't figure out. Then we ran aspects on that, and it is then when we figured out that the console is giving some out of sequence, I mean, it's writing out of sequence order, while aspect told us, I mean, the correct sequence of things.
Unfortunately, you don't have to run launch.
No, and unfortunately I couldn't recreate it because you also wanted to show it to any logic, but I tried, but I couldn't recreate the same scenario again. No, I don't because that code was out there. I mean, it was a very small code which I wrote at the very first go, and everything is changed now, so don't have that.
You want to go on and present oh, sorry.
Yeah.
So in addition to implementing the outputs of models, if there are folks into any logic or is there capability to capture the procedure of building a model if using graphical interface, for example, like in what sequence is a particular user building a model so that it's useful for other people to look at, for example, for training purposes.
In what sequence building a model means?
So you're adding parameters, you're building connections.
Oh, okay. You mean to say that how I am building a model, if some graphical interface is to trace that, then that can be used as a training material for.
Right, or for other purposes. Can you instrument that aspect of any logic?
I think you are talking about hooking up some like user interface tools with any logic and doing that, which I have plans in future to do very much, but I'm not sure how much I would succeed, or at this point of time I'm not sure how much can be done and how easily it can be done. But definitely the next step of this is to try and hook up certain user interface things to make certain things more flexible. And maybe like I have data, just blunt data, and which is very difficult to even, it's difficult to even go through that long trace logs and find everything out. So the next thing to it would be to show it like in some graphical way so that it's very easy to interpret and things like that.
Thinking about the recommended,
Yeah.
Or even, so the idea is you get to a successful model, but somebody might take 20 hours to do the same thing, right, than an expert can do because they know how to manage it. But even in, not necessarily in placing things in, but like, for example, you mentioned the function. Like the user is repeating the same line over and over. And you see the user do this somehow, this system. And so you might want to be able to have a recommendation saying, we notice that you've been using the same lines of code over and over. Would you like to use a function instead? And then direct them to a little help session on, or the tutorial on using functions. That's kind of the idea.
But isn't it something which needs to go inside the any logic? Because
yes, there's two levels of it though. So first of all, any logic is built on top of Eclipse, which is one of the probably the world's most popular platform for using
IDs.
development environments, and there are lots of tools like that in Eclipse that serve to try to recommend things or prompt things or make you aware of things. And so if any logic were supportive of third-party plugins to their Eclipse environment, that would be fundamentally enabling for that, because Eclipse is very well designed, and existing Eclipse tools do support some functionality like that. I mean, there's probably thousands of plugins now for Eclipse, that some of which do recommendations. But the other level is it is possible to also spy on what's going on using aspects about, oh, the user's doing this, the user's doing that, they're clicking on this thing. You could, in fact, do that, but it would be much better if any logic allowed us to plug into their Eclipse environment. And we're very keen on that idea, and I'll be talking with them about that in about 5 days, and see if we could get that opened up for third parties, not just ourselves, but others. Because I think it's something that would be very valuable for users. So Priyansri is going to now talk about a different tool that also uses aspects, but it's been built by a different student who's not able to be here, Winchell Chen, who's from our lab.
Put up his name and ID so that if anybody wants to ask him something. Winchell had been working on this tool that is data exporter to R. It is also using aspect-oriented language, and it is also configured in the same way that I configured my tool into a model. So the steps are same. You have to add the classes folder and the Java command. Those two steps are exactly the same. And this is going to create certain databases. It will export the databases to R, the data sets to R directly. We need to have R for that into our system, and we also need to have the tool configured. Like if you want to see, where am I? Sorry. In the dependencies tab, we again have the classes, and we have the Java command in the Java machine arguments So we are all set to run it. Before that, there is a manual which is present for this tool, and we would be uploading this into our into the folder, right, that we have for this bootcamp. So you all can refer to this one. And there are 5 steps actually to configure these tools. The initial, actually the first 3 steps relate to those 3 steps which I already explained in order to configure the tool into AnyLogic. So those are the same. I am not going through them once again. And the next set of steps are to configure R. Once you have R, you have to install this package SVSocket, which we have already in our system. And then we have to, for each session, actually we have to go through this commands, library SVSocket and then start socket server, which we have already done for now. So I'll just run this once and show you. Just I want to ask you one thing, since I'm not very comfortable with R, that I don't need to go through those socket server once again, right? We have already done that, and it's the same session. Yeah, I just can run once again and show them. So I'm speeding it up, and you can see in the console that things are getting recorded. Somehow I cannot select this. Yeah, now I can. Is it running? Doesn't seem to. Something is problem here. I'll start it once again. So it's completed. I'll close this.
Close the window too.
Close this window, yeah, okay. And yeah, we are in R, so let's see what are the data sets created. So we have got all of these. If we want to see one of them, like, let me copy some. So this is the data set here, and we can see it right from the console, and we can also see it within our folder. This is our folder, and as we can see, these are the data sets. We can actually match the timestamp 2:12 now. And that is all, I guess. What else?
Why don't you just plot that one out? Put a plot around it.
This one doesn't plot. Or is my command wrong? This should be fine. There was one that you.
It's multi. I see. Okay.
I am trying to find which one you plotted.
Infectious DS.
Yeah, I'll do the same. Infectious DS.
So I would have expected that to yield one. You may have to select for the field today.
Okay.
So those are the data sets exported. Okay. Well. Oh, I know. The window's hidden.
Oh.
It's hidden by that. It's just.
It's where do I need to go for that?
You need to go up here.
Here. Oh, I could. It's just hidden here. There you go. That's infectious DS, and this is removed DS. There you go.
Yeah.
Okay. Wow, there's one removed first.
Wow.
So this is the plot.
Yeah.
I'm sorry, I'm not very much aware about this tool. I'm just demonstrating it in front of you. So, Yeah, definitely.
Yeah, that's really cool.
We can provide all the stuffs in the folder, right?
Right.
Yeah.
So basically what happens is there's aspects within the model that without a line of code being written, because after it's configured with these two things, they basically, when you run the model and stop the model, they're going to take the data sets that are involved, put them out as Excel files, and then inject them into R through the sockets interface. And R will create them as new variables and then be able to refer to them. So then you could save them out from R as a, as a data set and place them elsewhere.
Yeah.
That's the basic gist of it. Very good.
That's great. And it records all data?
No, it records the data set.
Oh, whatever data set you've created.
Yeah, whatever. So remember, there's this data set object we could drag in.
Yeah.
That's what it records.
Okay, that's
the data
great.
set. Yeah.
Great.
Yeah. Now, in principle, it could be used to record other things too. And I think it may actually record other things. I'd have to check in the manual. It's the latest what it records, but I know it records data sets.
It recorded all these data sets for this particular.
It looks like it records some sort of bin lists and histogram data. It records data sets.
Bin data set, all histogram data.
Statistics discrete. It records various statistics being computed in the model. Yeah.
Yeah.
Good.
Okay. Thank you.
Thank you, Priyasri. Let's give Priyasri a hand.
Thank you. Thank you. So I guess you can delete those stuff.
Okay, great.
Thank you.
Great, thank you. And thank you, Priyasri, for overcoming all those big challenges. Right? A litany of woe